What if you could turn a large language model into a fully fledged microservice that remembers, reasons, calls APIs, and even collaborates with other agents? I spent 5 days doing exactly that, and today I'm breaking down every step of the 5-day AI Agent Intensive, the course that turned my toy projects into production-ready agentic software. And since I had completed the Gen AI intensive version of this course earlier this year, learning about Agent Development Kit (ADK) feels like a game changer. Let's dive in. What the 5-day intensive covers. Think of the course as a full software development lifecycle for agents. Day 1, Foundations and Single Agent Basics. Day 2, Tools plus Model Context Protocol. Day 3, Context Engineering, Sessions and Memory. Day 4, Observability, Logging and Evaluation. Day 5, Multi-Agent Orchestration, Agent-to-Agent Protocol, plus Production Deployment. Every day builds on previous one, and the final capstone pulls all the pieces together.
Today, we're really getting into something exciting. The architecture for AI agents.
That's right. We're focusing on the day 1 white paper from that 5-day of AI Agents Intensive course by Google x Kaggle.
Exactly. This feels like the guide for...
On day 1, the lab focused on the ease of creating agents using Google ADK package. It shows how to configure credentials, build a simple agent, run it with an in-memory runner, and launch the ADK Web UI for interactive debugging. Stepping through the code, the first section covers some basic setup, including installing packages and loading your Google API keys. Using ADK plus Gemini, I built a single agent that can conduct research on a given topic and call Google Search for up-to-date info. Here's the minimal code. To test, call the in-memory runner. That's it. Pass your test input into the Run Debug API. ADK handles the user-to-agent mappings. One of the coolest features is the ADK Web UI for interactive debugging. I use the ADK create command to wire up a simple agent that creates a folder with a Python file. Then call the ADK web command to pull up an interactive web UI that runs locally. Here is a short demo of what the ADK web UI looks like. You get a 360-degree view of the agent you selected, including tracing and event tracking, which we will cover later. Then there is the main chat area for interacting with your AI agent. Key takeaway: ADK simplifies wiring and orchestration. A single agent class, declarative tool definitions, and a built-in UI. It's a solid foundation that scales as you add complexity.
So today we're diving into what feels like the core question for anyone working with AI right now. How do you get these incredibly smart language models to actually do something useful in the real world?
Right. Because a powerful foundation model, it's brilliant.
Enter MCP, the Model Context Protocol. MCP standardizes the structured exchange between agents and tools, guaranteeing that the LLM receives JSON-compatible envelopes instead of raw strings. This prevents hallucinations when you need precise outcomes. In one of the labs, we dove into consuming external MCP services and handling long-running operations. In this example, I connected to the Everything MCP server, an NPM package designed for testing MCP integrations. It provides a getTinyImage tool that returns a simple test image, a 16 by 16 base 64 encoding. The MCP toolset is used to integrate an ADK agent with an MCP server. Let's define a simple image agent to test with. Run ADK Web and use the interactive web UI. Now, let's pass a simple prompt and inspect the output. The encoded image is received from the MCP server. I'll use an online image converter to see what we got back. And if we further inspect the MCP request response cycle, you will see our agent has access to all the tools provided by the Everything MCP server. MCP plus ADK's tool abstraction just fits in perfectly. It lets you safely plug in any external service, no more unnecessary string parsing, and no more prompt engineering just to extract fields.
Welcome back to the deep dive. Today we're jumping straight into something really fascinating, kind of complex, but super important in AI right now. We're talking about how you actually give a large language model a working brain, something like memory. And our main source for this is the day 3 white paper from that 5-day of AI agents intensive course by Google X Kaggle. Really great stuff in there.
Yeah, if you're thinking of building agents that, remember who you are, what you like, what you talked about last time, well, this paper is basically the blueprint. Our goal here is to kind of decode the key bits, the architecture you need to turn a basic LLM call into something stateful, persistent, and, well, genuinely smart feeling.
Exactly.
The vanilla LLM is stateless. Each call starts with a clean slate. Real assistants need session memory, what the user said minutes ago, and long-term memory, preferences, and past interactions. ADK's memory component abstracts embedding generation, store and retrieve, and TTL handling. You can also add a persistent memory layer, e.g., Firestore or DynamoDB, data that survives session resets. Key takeaway: memory plus session context transforms a question-answer bot into a personal assistant that can, for example, recommend movies based on prior likes or continue a multi-step troubleshooting flow across calls.
Welcome back, everyone. Today, we're jumping into something really fundamental for anyone building autonomous systems.
Yeah, we're taking a deep dive into the Google X Kaggle 5-day of AI agents.
Day 4 was all about making agents observable and debuggable. The key here is to treat them like any other microservice. For this, we instrumented 3 layers: logs, traces, and metrics. Logs are human-readable records of tool invocations and LLM responses. Traces are end-to-end execution graphs that show which agent calls which tool, when, and with what payload. And metrics are quantitative KPIs: latency, tool success rate, hallucination probability, and fallback frequency, amongst others. Key takeaway: observability plus evaluation turns a black box large language model into a maintainable service that you can monitor, debug, and continuously improve, which is critical for any production deployment.
So, you can whip up an AI agent prototype really fast these days, maybe just minutes, right? Fetch some data, make a basic decision. It looks great.
The demo is always impressive.
But here's the kicker, the sort of reality check from people actually deploying these things. Getting that cool demo into production, making it something the business can really rely on.
By day 5, we moved from a single notebook to a deployable, observable, multi-agent system ready for real-world workloads. Nice. All the pieces come together in my capstone project, a 911 emergency agent fleet, built on Google's Agent Development Kit. The system is a chain of 6 specialized agents that work end-to-end. Feel free to check out this video for a full breakdown of the capstone project. And that's it. If you found this breakdown useful, hit like, subscribe, and all that good stuff. I've linked the GitHub repo, the slide deck, and a quick start guide in the description. If you have any questions about ADK, MCP, A2A, or any general software engineering questions, feel free to drop them in the comments. And thanks for watching, and happy agent building.